Thanks, Vlad. Appreciate it. Good afternoon, everyone. My name is Paul Peterson, and I'm Vice President of Sales at Visolis. So the Visolis first platform molecule sells for $10,000 a kilogram in the market today. It goes into cosmetics. The Visolis team made $1 million worth of it in a week at a price point 90% less than that sales price I just mentioned. That highlights the power of synthetic biology. I'm here today to show you how we're bringing that power to the production of chemicals, materials, and polymers that are all bio-based and carbon negative. So at a very high level, we can take a variety of raw materials and via a fermentation process, produce a platform chemical that we call VPM1. We then do traditional chemical processing on that platform molecule to produce a wide range of other bio-based products that go into the markets you see here. This results in a very wide and diverse product portfolio that has a combined addressable market of over $10 billion just for one platform molecule. We also have more platform molecules in the pipeline with similar size addressable markets. I'd like to highlight just a couple of those end products just to kind of give you a feel, and feel free to reach out to me later on. I have some more data and some other products I'd like to talk to you about. The first one of which is a drop-in replacement for Isoprene, one of the largest chemicals used in today's market. So via our hybrid biothermocatalytic process, we can take fermentation, combine it with catalysis to produce very high yields of bio-based isoprene that are drop-in replacements for the isoprene used in the market today. Bio-based isoprene has been looked at from a straight fermentation point of view. However, it's never been successful because of the complex pathway and handling issues with the end chemical through the fermentation. So via our approach, we get very high yields of isoprene that's a lot easier to capture and handle materially wise. And this process that you see here is the same for the other chemicals that I'll talk about. The next one is a novel green solvent that's not used on the market today. In our limited solubility testing, it's shown very great solubility capabilities, similar to that to DCM or NMP, which are two hazardous materials that people are trying to replace today in the market. We believe there's a lot of new application potential with this product, especially in polymer recycling, as well as being an ideal replacement for those two things that are both REACH registered or about to be on REACH restriction lists. The second of which is another drop-in product. It's a petro-based diol called MPD that's used on the market today. Our technology allows for a less costly, more sustainable approach for this bio-based diol. The market for this has always been pretty limited. There's only one supplier because of the expensive production costs associated with it. And our technology should allow for the overall growth of this chemical into the market, as well as replacement of other petro-based diols, things like hexane diols that have a much larger addressable market. As I mentioned, we have more data available, and there's other bio-based chemicals in the portfolio. There's a wide range of products that we're able to produce. So I'm sure you're wondering about our ability to scale, and luckily for me, we have shown that. We've gone from lab scale to small commercial volumes in just 2 years. In fact, we're already sending kilogram samples quantities of all these different chemicals to our partners across the globe. And we have plans to increase our production 10x over the next 1 to 2 years via our recent JV acquisition. And next, this brings me back to the technology behind the platform. The key to our success moving forward is our ability to identify these platform molecules with large downstream addressable markets and then target those chemicals for production via a combination of synthetic biology and chemical catalysis. We support this approach with a back end of high throughput screening and machine learning in order to identify the key products and to deliver a complete technology package to our partners across the world. Actually, I want to go back real quick. Now, when you're thinking about this slide, or when you're looking at this, I want you to kind of think about how this could really evolve and kind of transition and evolve into the way bio-based chemicals can be produced in the future at a very large scale across the world. Just quickly want to highlight the team. We're led by our founder, Dr. Deepak Dugar, and we're lucky enough to have some great scientific advisors that have helped us get to where we are today. We're located in the Bay Area and have about 15 full-time scientists that we have on staff, both upstream and downstream for the fermentation and catalysis. Here's some of the funding that we've received thus far. The company has been strictly funded through government grants. So if there's any questions, I'd love to answer that and look forward to speaking to everybody. Thank you. Any questions from anyone? Can't really see this light's blinding. No? Okay, I'm right back there. If there's any questions, please feel free. Thank you.